Hello, my name is Anton, I will guide you through this tutorial. In this tutorial we are going to look at functions and procedures in VHDL. These very useful tools can significantly increase the readability and reusability of your code. Eventually, we will use onFunction and procedure for a simple counter on the 7-segment display. Let's start. First include standard logic and numeric standard libraries. Good, now we declare entity. In this tutorial we need all 4 7-segment displays, switches, keys and 50 MHz clock. The 7-segment display is an output of type standard logic vector, 6 down to 0. While writing the boring part, I will explain what functions and procedures are. Functions and procedures are small subprograms. Like a process, they contain statements which are executed sequentially. But subprograms itself can be placed inside the concurrent or sequential part of your architecture. We will see how this property can keep your code short, reusable and user-friendly. The main difference between function and procedure is that function receives some input values and produces only one return value, while procedures can have multiple outputs without any return value. Both subprograms must be defined by user first. The convenient way to do it is to use packages. This is like your own library you can then include in any project. Okay, as you can see, I added all inputs and outputs to our entity. Now we can start writing a new package. To do so, open new VHDL file. In our package, we will use the same libraries as in our top entity, so I just copy-paste them. The package itself consists of package declaration and package body. In declaration part, we just declare our function and procedure, define its inputs, outputs, and so on. Since we are going to program a counter for 7-segment display, let us write a function that will convert an integer into a corresponding pattern on the display of type standard logic vector. First you write function, then its name. Next, write in brackets what arguments it should receive. In our case, it will receive one argument a of type integer and return standard logic vector. Note, there is no range for input and return values. You can specify it later or leave the range be also variable. Next, we describe our function in the package body. But before we do it, there is one more important thing about subprograms. You can declare signals inside them. Instead, you use variable. In comparison to the signal, a variable is only visible inside a process, function or procedure is declaring, similar to the local and global variables in common programming language. The function description starts with this declaration, but instead of semicolon, you write is. Between begin and end, we place sequential statements. The function itself is pretty simple. We take a number of type integer and convert it into a vector, which will show this number on the 7-segment display. For example, if you want to display 1, we switch the first and the second segments on, while others will be off. The function will return the variable result of type standard logic vector 6 down to 0. The conversion is also simple. We just cover all possible values of the argument A in a single case statement. Depending on the number, the suited vector is assigned to result. Okay, you get the point, I will skip this part. Almost done. Let's say if the function input is not in the covered range, fill the vector with zeros. After the case statement, the function returns the result. Perfect, now let's check if everything is working as intended. First, add the package to your project. Good, now let's write a simple code that will take first 3 switches as binary input, convert it to integer and pass through a function. Finally, the return value of the function is assigned to the 7-segment display. If everything is right, we will see a number on the display according to the state of the first 3 switches on DE1 Altera board. Next we call the function. In brackets we pass to it its argument number. As you can see, the function call is the same as in any other programming language. The return value is finally assigned to hex 0. Note we don't use any process in our test. At this point I want to explain you what we are going to program next. Our final goal is a counter that will run on all 4 displays. In order to do this, we need to split one signal into 4 different signals. Since functions have only one return value, we will take a look at procedure. As with functions, we need to declare procedure first in the package part. In procedure declaration, we need to specify if input and output is signal, variable or constant. Unlike functions, procedure arguments must have defined range. As discussed before, the output consists of 4 signals of type integer, range 0 to 9. Next, let's write an algorithm for splitting an input value. The idea is simple. First we look if a value is bigger than 999, if so then divide the value by 1000 to see how many thousands are in the given number. The result of this division is then assigned to the fourth number. Next, we subtract all thousands from the number and look how many hundreds are in the rest, and so on until we reach ones. Note, in VHDL, division will return the whole number, so if you divide 255 by 100, you will get 2 as a result. The rest is just discarded, no rounding is done. The variable temp will hold the number while going through all 3 steps. Since a procedure reads the division result and output can be read, we need to buffer each output with a variable. At the beginning, temp takes the input value. Then we check if the value is greater than 999. If not, digit 4 is assigned 0, since the value is less than 1000. All 3 steps are similar, so I just copy paste here and change some values. At the end we assign the results to the output signals. Alright, now I will write a simple counter from 0 to 9999 with some features. By pressing the key, you can change the counting direction, and I will also implement a prescaler with a variable maximum value. The signals sec1 to sec4 are holding the procedure's output values. Next, these output values are converted by a function into the 7 segment vectors, which are eventually assigned to the display inputs. The counter itself is pretty simple, so I will not comment here a lot. The prescaler maximum value is adjustable through 10 switches. By the way, if you like this tutorial, give it a thumbs up. Okay, the counter is done, let's call the procedure outside the process, just because we can. In brackets we write its inputs and outputs, in the same order as they are defined in the package. So first comes the input value, then 4 outputs. The converted output of the procedure is assigned to the display.